Okay, so we'll start with our very last chapter in Stats 2. Alright, but this is a new chapter lah. That means the concept is something new to us. And then, but of course, there are basic concept like normal distribution, Poisson, binomial, all the distribution that you learned before, we will apply it here. Okay, so this chapter we are going to talk about hypothesis test. Okay, so generally I separate it into three parts. So here you can see that we are having part 1, which is about the test for continuous random variable. And then we have the second part, which is about the discrete random variable. Okay, and then for the third part, which is also the hardest topic lah, so I call it as errors. Is it? Okay, so error. Alright, so there are three parts here. So this is actually a long chapter to us. Alright, so I think you'll have quite a number of videos from this chapter. Alright, so for part number 1 and part number 2, mainly we focus on how to do a test for continuous and also the discrete random variable. Alright, so for this video, we are going to spend a longer time to explain all the basic terms that we are going to use it very frequently in this chapter. Alright, and after that, you need to combine all the knowledge that you learn in Stats 2 and also in Stats 1 to apply it in the error part. Okay, so the basic is very important for the hypothesis test. So part 1 and 2 are very important. Okay, but once you understand the process of carrying out the test correctly, then generally, right, to me now it is quite standard one. The process is quite standard. The steps are quite standard, but you need to know all the small details, right? Okay. So we will start with some basic terms first and also the basic idea about the hypothesis test. Okay. Alright, so let's talk about the introduction part, the procedure of hypothesis testing. So first you need to know the nature of a hypothesis test, the difference between one-tier and two-tier test. So you'll see these two words very often later, one-tier or two-tier test, and the terms like null hypothesis, alternative hypothesis, significance level, rejection region, or we call as critical region, acceptance region, and also test statistics. So all the words here, all the terms here, you might not see them before, or maybe after you see, you also don't know what's the meaning. But generally, once you roughly know the meaning or the basic idea about all the terms, then you roughly know what the test is about. Okay, so we are going to discuss all the terms here. All right, so in short, actually, although all the terms looks very new to most of us, but generally it is just a definition. All right, like what is null hypothesis? It is a definition, actually it is fixed. So you just need to know the meaning. Okay, so let's start. Okay, so what is a hypothesis? So hypothesis is a statement about the value of a population parameter developed for a purpose of testing. So it should be testable either by experiment or observation. So hypothesis means a sentence or a statement, okay, to let you test whether this statement is true or is it false. All right, so it should be testable either by experiment or observation. Okay, so like for those who study science, when you carry out some experiment in labs, right, actually you are testing something. Okay, so it is a kind of test as well. All right, so like for maths, for us, right, mainly we are using the calculation to run the test. All right, we use all the data, all right, to carry out a test. So it is not practical. For maths one, mainly we are using calculation, not the hands-on one. So for sciences, they are using hands-on method, okay, to carry out the experiment, okay, to decide whether a particular statement or hypothesis is true or false. All right, okay, so there are example of test hypothesis. So let's say there's a principal at the school claims that the student in his school are above average intelligence. One of the sentence below is true. So students in this school are not above average intelligence, and then the student in this school are above intelligence. Okay, so usually the hypothesis, right, comes in pair. For maths, our definition is when you want to carry out the hypothesis test, your hypothesis or statements should come in a pair. All right, so this pair of statements, they are having different meaning, totally opposite meaning. Okay, so like for this example, the principal said that the students from his school are above average. But of course, every principal also wish that their students are intelligent one, right? Okay, to gain reputation for the school. Okay, so we want to test whether this claim is true or false. So we need to carry out the hypothesis test to see whether is it true or false. So when you want to carry out the hypothesis test, usually we will write out the statements in a pad. So you will see that this is something I want to test whether is it true or not. This is something that the principal said one. So we want to see whether is it true or not. And then we have another statement which is totally the opposite meaning of what you want to test. Okay, all right. So all this we call them as hypothesis. All right. So that's the meaning of hypothesis. Okay. So the correct sentence can be determined by carrying out a test using the IQ score of a random sample of students from this school. All right. So how to carry out the test? You can collect some data like the IQ score, and then you try to do some calculation to decide whether should you accept the claim or reject the claim. Okay, so this is one of the basic example that we have lah. But of course, I didn't show you how to carry out the test yet, right? But just to let you know the idea. Okay, so let's have a look for second part. Okay, so let's say there's a researcher thinks. Okay, so I think there's a typo here. It should be K, right? So thinks that if knee surgery patient go physical therapy twice a week instead of 3 times, their recovery period will be longer than 2 months. So they are thinking that if let's say they reduce the number of time for the physical therapy in a week, then the recovery period will be longer than 2 months. So this is something that they want to test. So how to write out the statement to be tested? So the statement will be the recovery period is longer than 2 months or not longer than 2 months. So again, you can see that this is something that we want to test and see whether is it correct or wrong. And then this one is the opposite meaning of the statements that we want to test. All right, so again, this pair of statements, we call them as hypothesis. Okay, so how to carry out the test if let's say we want to use mathematical methods. So you can use the mean recovery period of a random sample of knee surgery patients that go to physical therapy twice a week. All right, so you can see that every time when we want to test any statement, they must come in pair. So we call them as hypothesis. All right, so you see that we are having two sentences here, right? So the hypothesis here, they are having special name actually. All right, so the name of this hypothesis is null hypothesis. Another one, we call them as alternative hypothesis. So the standard symbol for null hypothesis is H0. The alternative hypothesis symbol will be H1. For some of the particular book, you will see that they might use HO and also HA. Also acceptable. All right, but I think for A-level, we are using H0 and H1. Okay or not? So this is null hypothesis and we are having alternative hypothesis. So which one is null hypothesis? So for null hypothesis, usually we will assume it to be true until we can prove otherwise. And then for the alternative hypothesis, it will be accepted as true if we can disprove null hypothesis. Because if you look at the sentence that we have, the statements that we have just now, right? Only one of them will be the correct one. It is impossible that both of them correct, right? So if you accept this, that means you reject this. If you accept alternative, that means you reject the null. Okay, all right. So only one of them will be the correct statements after you carry out the test. So we need to go through the process of how to decide are we going to accept the null or accept the alternative. All right. Okay. Then now, how are we going to decide which statement is null hypothesis and which is the alternative hypothesis? Okay, so let's go through with some details here. There are a few things that you need to know about H1 and H0. Okay, so H0 and H1 are mutually exclusive and collectively exhaustive. So I mentioned to you earlier that these two statements are having totally opposite meaning. Okay, H0 is always presumed to be true. H1 has the burden of proof. Okay, so if let's say you don't really understand the meaning here, then you can actually use a mathematical symbol to help you to decide. So when you try to write out the statement in a symbol form, and you realize that when you are having equal sign, greater equal sign, smaller equal sign, then it is always the null hypothesis. So we use the mathematical symbol to help us. So as long as your symbol got equal sign, then it belongs to null hypothesis. But when you are having the inequality, like not equal to, smaller or greater, there's no equal sign here, right? So all these kind of statements belongs to H1. All right, so because to some of the students, right, they feel very difficult to decide or determine, okay, which one is H now and which one is H1, the alternative. So to me, right, the best way is by looking at the symbol. If your symbol got equal sign, definitely it will be null hypothesis, and then without the equal sign, definitely it will be the alternative hypothesis. Okay, all right, so if you continue further, so this is a very important concept and idea to teach you or to guide you how to decide the alternative or the null hypothesis. Okay, so when you want to solve the problem, right, they usually will give you a very long paragraph, and then to decide whether it belongs to null or alternative hypothesis, then you always look at all the words like when they say about larger than or more than, so the symbol will be greater than, no equal sign, so it is actually part of alternative. Okay, so let's say in the question, if you see the word not more than something, not more than, when you try to write it out in a symbol form, so it should be smaller or equals to, and therefore you will see that it belongs to, got equal sign, right? So it belongs to the null hypothesis. Okay, so or maybe when they ask, is there any difference for the mean of the population? So is there any difference or not? So you don't know whether it's equal or not equal whatsoever. So it is not equal. So when you didn't see any equal sign here, that means it belongs to alternative hypothesis. So of course, all these are some examples only, okay, to guide you, okay, to see whether the statement in the question itself, which one belongs to alternative and which one belongs to null. All right, so we will have a lot more different words being used in the real question. All right, so all these are just some simple example, okay, some simple example to let you have a look. All right, so you will see that every time when I look at a word, important keywords, I will translate it into the symbol first. Then from the symbol only I decide whether it belongs to alternative or it belongs to null hypothesis. Okay. All right, so for now, you know the very first basic idea about the null and alternative hypothesis already. So let us start to build all the statements, okay, to form all the null and alternative hypothesis. Okay, so usually in the exam style question, they will give you a long question in a paragraph. So from there, you need to look for the keyword. You need to write out the null and alternative hypothesis by your own. Okay, so let's have a look for part one. Okay, so in the past, an athlete has run 100 meters in 10.3 seconds on average. He has been following a new training program which he hopes will decrease the time. So I think will decrease is a keyword, okay, to help you in forming the alternative or the null hypothesis. So maybe you can highlight the word will decrease first. The time he takes to run 100 meters. He's going to time himself on his next 6 runs. All right, so from this paragraph, we want to form the null and alternative hypothesis. Okay, so first of all, I just want to tell you for this part, right, we are going to test everything about the mean, the population mean. Okay, so you can see that from here, 10.3 seconds on average. It is actually the old record that he has before he followed the new training program. And after he tried the new training program, he want to see whether got improvement or not. All right, so how to test whether really got improvement or not? So it doesn't depends on one or two result, okay, after he attend the training program one. So we actually need to do some calculation. Okay, so to test this whole thing, all right, to see whether the new training program effective or not, then he need to carry out a test. Also, to carry out a test, you need to write out the hypothesis. So you will have the null hypothesis, okay, and also the alternative hypothesis. All right, so again, we are going to test the population mean, okay. So now, when they say the mean will decrease, which means will decrease means decrease means become smaller, right? So it means that you want to have the mean become smaller than the original mean that we have, which is 10.3 seconds. Okay, so from this keyword, you can translate it into this symbol, right? No equal sign. So you see mu smaller than 10.3 seconds, no equal sign, that means this particular statement belongs to alternative hypothesis. So when we write out, we write as mu smaller than 10.3 seconds. Okay, and then for null hypothesis, it will be totally opposite meaning from the alternative hypothesis. So if your alternative hypothesis is smaller, so your null hypothesis should be mu greater or equals to 10.3 seconds. Okay, so understand how we form this or not? So you need to find out a useful keyword in the question first about something that you want to test, and then you translate it into a symbol. And from the symbol, you see whether do you have any equal sign or not in it. If have equal sign, then this will belong to null hypothesis H0. But if you are looking at this side, it is smaller, no equal sign. So no equal sign means that it belongs to alternative. Therefore, the null hypothesis, you just write out the symbol which is the opposite, okay, totally opposite of the alternative sign. Yeah, all right. And then generally, this is what we have for our null and alternative hypothesis. And for my practice, usually I will prefer students to write out the meaning of this alternative hypothesis. So that means if let's say the alternative hypothesis mu smaller than 10.3 seconds means what? Means that the new training program actually will decrease the time he takes, right? The time he takes or the athlete takes to run the 100 meter. All right, so there are reasons why I want you to write the statement here because of at least maybe towards the end of the test, after you carry out all the process, right? When you want to make a conclusion, it is easier for you to refer to the sentence that you write here. Because there are a lot of students, they know how to write a symbol, but they actually don't know what's the meaning of the test at all. All right, so when you want to carry out the test, you must know what is the meaning of all these symbols first and what's the meaning for this sentence. Okay, for the alternative hypothesis in a sentence form lah. So I write out in a sentence form. So very clearly that you can see that if let's say this is true, right? Alternative hypothesis is true. It means what? It means that the new training program will decrease the time the athlete takes to run the 100 meter. Okay, so this particular sentence in the exam they won't give you any extra marks. But for me, I think it is a good practice for you to write out. Okay. So far any problem or not? So for the first part A, we already complete the very first step of a test. So that means you need to know how to write out the null and alternative hypothesis. Okay? Alright, so if no problem, then we can discuss another example. Okay, let's have a look for part B. Okay, so for part B, they are talking about the sugar weight, the sugar mass, right? Okay, so for sugar mass, generally they are having the mean value of 1.01, and then a sample is taken in order to test whether there has been any change in the mean. Okay, so they are asking about is there any changes in the mean or not for the mass of sugar. Okay, so the keyword is any change in this paragraph, and after that how can I write out the symbol for any changes? So when they're asking for any changes means that it might become less or it might become more, right? It can be two direction. Therefore, when you write out, you don't know whether it will become greater or smaller. We will write as non-equal. So the mu is not equal to 1.01 kg. Right, so this particular word, you can translate it into the symbol, which is non-equal to. And then again, as what I told you just now, for this part, we only focus on testing the population mean. Okay, all right. Any changes in mean, so you can translate into this symbol. So if you look at the non-equal sign, there's no equal sign, right? Therefore, this symbol belongs to which hypothesis? So it will belongs to alternative hypothesis. Okay, and therefore the null hypothesis will be mu equals to 1.01 kg. Then when you want to write out the sentence, what's the meaning for mu not equals to 1.01 kg? So you can write out from the sentence here, the paragraph, the question. So you can say that there has been changes in the mean of the bag of sugar. Okay, so far any problem? I hope that you roughly know the idea how to form it. Okay, then maybe I can try another example with you. Then I will maybe leave the rest for you yourself to carry it out. Okay, to try out. Okay, so let's have a look for part C. Okay, so for part C, they are talking about the mean volume of liquid in bottles of lemonade should be at least 2 liters. So at least 2 liters to me is one of the keyword. A sample of bottle is taken in order to test whether the mean volume has fallen below 2 liters. So this is another keyword here. Okay, so when we are talking about fallen below 2 liters, means that mu is less than 2 liters. Okay, and then for this one, at least 2 liters means what? Means that mu is greater or equals to 2 liters, at least, right? So 2 liters. So for this question itself, they already give you the two keywords, and also you already can write out the null and alternative hypothesis statements straight away. So for this one, it should be mu greater equals to 2 liters. Got equal sign one, you put it under the null hypothesis, and then this one has no equal sign, then you put it under the alternative hypothesis. Okay, so what is the meaning of the sentence here for alternative hypothesis? So you can say that the mean volume, okay, of the lemonade has fallen. Okay, so has fallen below 2 liters. Has fallen below 2 liters. Okay, so I think this is not hard now. You just look at the keyword, translate it into the symbol, and then decide whether you should put it under alternative or null hypothesis. Okay, all right. Okay, so before you continue to complete the rest of the example here, there are something that I want to tell you again. Right, so if you refer to the three example that we discussed just now, so I told you, right, anything with the equal sign, we will put it under the null hypothesis. Okay, and then for A-level syllabus, because they want to make sure that it doesn't look too complicated, you want to make the, how to say, to make the hypothesis looks easier. Okay, generally for the null hypothesis, they will not put greater equal one. For A-level syllabus, the marking scheme, if you look at it now, they will always put equal sign only. Okay, but actually for some other reference book or what, they will still put greater equal sign. This is the original answer. Okay, but for A-level syllabus, they will just change it into a simple way. So they will always put the null hypothesis as equal sign. Okay, so in exam, you just put equal sign. Understand or not? But of course, all this, the symbol smaller and greater or whatsoever, you still get the keyword from the question. All right. Okay, so second example also the same. This is equal sign. Okay, and then the third example. So you see just now when you write out it is greater equal sign, right? But in syllabus or maybe in the marking scheme, we will just put it as the equal sign only, although the original meaning is greater equal. Okay, all right. So this is a small detail that you need to know lah. In case in the future when you want to check the marking scheme, you'll realize, why they always put equal sign only? All right, so they just want to make it simple, but the original concept is what I told you just now. Okay, so originally it should be greater equal one, just that they want to make it simple. All right, okay, so now I will want you to pause this video and then please complete example D until example H. All right, so I'm not going to discuss all the example in detail with you already, but I will just write out the answer for the null and alternative hypothesis. Okay, so please make sure that you pause the video now and attempt all the example first. So at the same time now, I will try to write out all the answer. So for part D, this is the keyword less than. All right, so when I write out the null hypothesis, it will be mu equals to 102.5 gram. And then for the alternative hypothesis, it will be mu smaller than 102.5 gram. Okay, so you write out the sentence yourself lah. The mean mass of chocobar is less than 102.5 gram. Okay, all right, so this is the answer for part D. And then for part E, if you look at the detail, all right, so new procedure results in a different assembly time, so different. Okay, originally it is equals to 84, so now they want to see whether is it different or not. So because of the keyword different, so you should have mu equals to 84 seconds, then the alternative should be mu not equals to 84 seconds. Then again you write out the sentence yourself lah. Okay, so this is part E. How about part F? Right, so for part F, they talk about the average age of all hospital patients was 53, and then a newspaper believed that this figure is an underestimate. All right, so keyword is underestimate. What's the meaning of underestimate? It means that 53 is something that you underestimated, so it should be more than 53. Yeah, so this is a word that might make you feel confused. So 53 years is something underestimated, so that means when you write out the symbol, it should be mu. They think that it should be more than 53 years. Therefore, when you want to write out the symbol, okay, so it will be mu equals to 53 years. And this one will be mu more than 53 years. Okay, so this word is a bit tricky lah when you look at it. All right, then you write out the sentence by yourself. Okay. Then next one, how about the answer for part G? Okay, so for part G, a manufacturer certain battery claims that it has a mean life of 30 hours, and then a suspicious customer wishes to test the claim. So when the manufacturer say that the battery claims has a mean life of 30 hours, means that the mean is equals to 30 hours. Okay, so what will be the answer? So very obvious, the keyword mean life have 30 hours means mu equals to 30 hours. How about the alternative hypothesis? Okay, so for the alternative hypothesis, it is actually mu smaller than 30 hours. Okay, so maybe I think some of you or maybe quite a number of you will ask already lah, why is it smaller than it is not equals to? Because from the question you already get equal, right, for now. So for the alternative, it should be not equals to. But why this is wrong? Okay, so let me explain a little bit about this. So now, if you look at this question, they are talking about the life of a battery. So it is something like warranty. Okay, when the boss selling the battery say that okay lah, you can use this battery until 30 hours. Okay, it can tahan until 30 hours. It can stand for 30 hours. All right. So you as a customer, okay, if you buy the battery and then you go back and use, if the battery life is less than 30 hours, much more lower than 30 hours, of course, definitely you will go back and argue with the boss, right? Saying that, oh, why this is not true because it cannot stand for 30 hours. It is much more lower. But if let's say this particular battery, you can use it for much more higher than 30 hours, are you going to take the battery again and go and argue with the boss or not? So most of the customer won't do that, correct or not? Okay. So when you want to test, we are only testing for any battery life or any product life. We always test for lower than the guarantee time. All right, guarantee time. Okay, so for this question itself, it should be smaller than or not equals to. All right, but some students they will argue like, okay, but according to the question, I can still want to test for non-equal sign one. So actually, this question is quite confusing or quite tricky. So usually for A-level exam, they will ask you this question. But I put it here to let you try to understand better. When we are talking about guarantee period, mean lifetime for the product and so on, usually we will only test for the lower one, not more than the guarantee time one. Understand what I say or not? Okay, so for this particular example, we just put it here for discussion. All right, so just to let you aware that you might have this kind of question. I mean, you might need to understand how this kind of question, when you face it, how are you going to test it? All right, because for me, in my opinion, I'm not going to test something that is more than the warranty time one. We are not going to complain about that. Okay, all right. So the answer is smaller. To me, the answer is smaller. All right. Okay, then for part H, the answer, the keyword is at least 5 microfarads. So because of this keyword at least, therefore your null hypothesis will be mu more than or equals to, right? More than, at least is more than or equals to 5 microfarads. I don't know why is that. Okay, but for alternative hypothesis, it will be mu smaller than 5. It's the opposite meaning of your greater equals to, right? The at least means greater equals to. But because of our syllabus, how to say standard, so we will just change into the equal sign. So this should be the correct answer. Okay, so no matter how, I hope that you really go through with all this example and then you roughly have the idea how to form the null and alternative hypothesis correctly. Okay, all right, so after this, what is the next one? After you know how to form the null and alternative hypothesis already, then we are going to decide whether the test that you are going to carry out is one-tail test or two-tail test. Okay, so what is the meaning of one-tail test? So one-tail test means that your hypothesis propose a change in one direction only. In short, that means when your alternative hypothesis, you're having more than or less than, so it belongs to one-tail test. You are only looking at the alternative hypothesis because null hypothesis is always equal. All right, so to decide whether is it one-tail test or two-tail test, you need to look at the alternative. So if two-tail test, which means your alternative hypothesis is having non-equal sign. So this is two-tail test. Okay, so the second thing, after you form the null and alternative hypothesis already, then you need to decide are they one-tail or two-tail test. Okay, so let us go through very fast again about the example that we tried just now. Okay, so example 1, is it one-tail test or two-tail test? So this one side smaller only, right? So one tail. Okay, one tail. So this one, not equal sign, so two-tail test. How about this? One tail test also. Okay, then this one, one-tail test. This one, two-tail test. This one, one-tail test. Okay, this also one-tail test. This one also one-tail test. Very easy to determine, right? Okay, you just look at the sign of your alternative hypothesis. So that's the next thing that you need to know. Okay, decide whether is it one-tail or two-tail test. Okay, then after that, after you carry out, you go through with these steps already, form the alternative and null hypothesis. After you decide whether is it one-tail or two-tail test, let's have a look for all these keywords that you are going to see it very often, all right, in your question later. Okay, so first of all, you need to know what is test statistic. Okay, so in short, right, I will just tell you test statistic is something you calculated from the sample. So we call it as test statistic. So this is your own calculation. Okay, so rejection region or critical region. These two have the same meaning, rejection or critical region. Okay, so rejection or critical region means that you reject, at this area, you reject the null hypothesis. Okay, so when we say rejection region means you reject what? You reject the null hypothesis. Okay, so when you talk about acceptance region, so what you accept the, not to say accept, like you say that null hypothesis is not rejected. So you will see that the acceptance region and rejection region, right, our standard is based on the null hypothesis, because we always assume that the null hypothesis is true until you prove that it is wrong, it is not true. Okay, so for all our calculation here, our rejection region and acceptance region, we also based on the null hypothesis one. Okay, all right, then after that we are having the critical values. So critical values means that the line that separate the rejection and also the acceptance region. So as an example, like if let's say this is rejection region, right? Okay, this is acceptance region, let's say lah. So the line that separate the rejection and acceptance region we call as critical value. Okay, so usually for this critical value, usually you can find it out from the table, or maybe it will be given in the question, usually. Alright, so this is what we call as critical value. So again, test statistic is something that you calculate. Critical value is something that you can find out from the table or will be given by the question. Okay, and then after that, we talk about significance level. Alright, so significance level means that how strong you want the test to be. Okay, the significance level. So significance level usually is quite small. It will be good if let's say you're having a smaller percentage. Usually you'll give it in percentage, like maybe they tell you I want to carry out the test at 1% significance level, or maybe I want to carry out the test at 5% significance level or 10% significance level. Okay, and then for your information, right, significance level is actually the opposite area for the confidence level. We learn confidence level in chapter 4, right? So if let's say we are having significance level 1%, that means you are having the confidence level at 99%. Okay, so if let's say your significance level is 5, so your confidence level is 95. So when you add up these two, the total is 100%. Okay, but when we want to carry out the test, we are using the word significance level, not the confidence level, because confidence level we are using it to find the confidence interval, but when we want to carry out the test, we are using the significance level. Okay, so that means what? That means if let's say you are having a small significance level, that means the test that you carry out is strict. If let's say when you use a larger value for significance level, that means the test that you carry out is not so strict, it's more lenient. Okay, because you have a wider area to reject the null hypothesis. Okay. Alright, so all these are the very important keywords that you need to know the meaning. But of course, when you try to carry out the test, I will still explain all these keywords to you again. All right, but for now, all this definition, you need to roughly know about it first. Okay, then continue again. All right, so when you want to carry out the test, right, generally, it will be useful. Usually for me, I will ask the students if can you try to draw the figure to help you, the diagram to help you. Okay, so you will see that I have three diagram here, attached three diagram here that we will use it very frequently when carrying out the test in this part, in part one, the continuous random variable. So for continuous random variable, when you want to carry out the test, we are always testing about the normal distribution. Okay, so usually I will tell students, you try to draw the figure, okay, when you carry out the test in normal distribution. So there are three types here. So we have one tail test bracket left, one tail test bracket right, and also two tail test, non-directional test. Okay, so when do you need to draw all the graph here? Okay, so for one tail test left, you need to draw it when your alternative hypothesis belongs to mu smaller than a number. So you need to draw this particular graph. Okay. Then for one tail test right, it will be stand for alternative hypothesis mu more than a number. Okay. So this is smaller, this is larger, and after that for two tail test, when you draw it, you are drawing it for the alternative hypothesis not equals to a number. Alright, so you draw two tail tests. So what's the difference between one tail test left, one tail test right, and also two tail tests? Generally, it's like that. When you're having one tail test left, when you're having smaller, you will see that your rejection region is on the left. Only on the left. Right hand side is clear. And this small area here, how I know how big is the area? So this area is actually alpha. So what is alpha? Alpha is the significance level. So usually the significance level will be given in the question. So that means if your alpha is smaller, then the area is smaller. So your test will be stricter. Okay. And then so this area, the smaller area here will be the rejection region because all these are extreme value, right? So for extreme value, usually we'll reject. All right. Okay, so this is how I try to remember the graph or I try to interpret the graph. Okay, so alpha, how big is this area again? It will be decided by the alpha significance level. All right, so this is rejection region. And therefore, the rest of the graph will be the acceptance region. So as what I told you just now, the line, the value that separate the rejection and acceptance region, we will call it as critical value. So this critical value, we will try to find out from the normal distribution table later. Okay, then let us continue with one tail test right hand side. So for one tail test right, so your alternative is mu greater than a number, greater. So you will see that when you draw the graph, your rejection region is on the right. Okay, so again, this area on the right, how big is it? It is affected by the significance level also. And the standard symbol for significance level is alpha. Okay, so again, the white color part will be non-acceptance region, will be acceptance region. So this value itself is the critical value. Okay, then when we proceed to the next one, two-tail test. So as what you can observe, two-tail test, so not equals to, and you are having two rejection region on both left hand side and also right hand side. Okay, so this two-tail test is a bit special because the area on the left and the right hand side is actually half of the significance level. You can see that this is half alpha and this is half alpha, so that when you total them up, it becomes alpha. Okay, so it is actually alpha divided by 2 lah. So this is something special about the two-tail test. Okay, so all the graph here to me, right? When we just started to learn the hypothesis test, I will think that it is very, very, very useful. So usually I will tell students, if can, you try to draw it out. to help you to understand better in your basic. Okay, and at least you can you visualize, you can have something to refer, okay, when you are carrying out the test. Right. Okay, so these are the graph that is very useful in our hypothesis test process. Okay, then for this video, generally it comes to the end already because I already introduced all the keyword and all the important concept about the null alternative hypothesis and also the basic terms already. Okay, so for next video, we are going into the detail of carrying out the test. All right, so for our syllabus, we are going to learn two approach for the hypothesis test. The first one is critical value. The second one is p-value. All right, so these two methods will be discussed in the next video. All right, so for now, I will stop here.